Hi, welcome back to Home Time. Well, the action continues here at the Creekside home as we make the transition from foundation to framing. For the foundation, we'll be filling the basement walls with concrete to finish off the ICF system, and that's kind of a fun process to watch. We'll also be very diligent with the waterproofing process on the outside of those forms, so you'll see a great way to be sure you get a dry basement. So we moved right into the footings and the first batch of insulated concrete forms. Well, we got some cold and stormy weather about that time, but there was enough of a break to pour those short walls and get them waterproofed. Then we started stacking the rest of the basement walls with some more ICFs. Now, we talked about these quite a bit already. These ICF forms are basically two pieces of extruded polystyrene, 2.5 inches thick, with these plastic ties in the middle that provide the structure, hold everything together. They also do a beautiful job of positioning the rebar right in the middle where it should be, and it stays in that spot when they pour all the concrete. They also have these nailing or screwing flanges right along the outside and the inside that make it very easy to attach all your finished materials. We had Brad Kvanbeck's crew here handling all the forms, and they go together kind of like Lego, so they stack pretty quickly. They're much lighter than concrete blocks, so bracing's kind of an issue as the walls rise up higher and higher, but they've got a system to keep the forms nice and plumb, as well as very rigid when it comes time to pour the concrete. Of course, there's also plenty of rebar laid in there horizontally and vertically to help keep the concrete solid after it cures. So throughout the whole process here, we've been keeping Brad and the boys supplied in rebar, working with a local company. Now what's nice is we can give this company our plan, and then they can do a lot of the pre-cutting to length of some of the different footings and stuff, as well as some of the wall sections. But what's really great is they can bend up some of the steel. Saves the guys a lot of time on location. So you look at some of these wall sections, it's great to get these things already pre-bent, cut to length, so they just pop them into that the position on the wall. Look at some of these zigzagging walls that we have going. It's a lot easier to be able to work with something like this than to measure and bend it on site. And this little guy here is called a stirrup. This is all pre-bent. This goes into the brick or the stone ledge. You just slide it in there. They wire it up to the rebar that's running through the ICF, and they're all set for the pour. Now what's nice is they can do a computer 3D model of the house. In other words, model it before you actually build the house. Of course, the emphasis is on the rebar, but you're able to take a look to see how that rebar is working through the structure before you actually start the construction. And of course, all this is based on what our engineer is recommending. So now it's time for the pour. Now there's a couple of connectors designed specifically for attaching your ledger board around the top of our wall. A couple like this. This one actually goes into the ICF form itself. This sits flat on the outside. When the concrete's poured, it goes right into these holes, and this does a beautiful job of anchoring that right to the ICF. And then when it's time to put the ledger board on, the ledger board fits right in this slot, and then this one screws right to the face like that. And it really does a nice job of holding it. You don't have to worry about that ever coming out. But for now, we just need to have the first ones in place along the top of the form where that ledger board will end up going before we hang the floor trusses. We cut slots for each leg, set the connector in place, and then drive in a small screw to hold it firmly in place while the concrete's poured. To position them, we're using a level line that reflects the bottom of the ledger board, so you can use that to line up the bottom of the plate and mark off the slots for the legs. It doesn't take much to cut those in. You just want to make sure that each one is centered on one of the plastic webs, so when you drive in the screws, they hit something solid enough to hold them in place during the pour. There's a tendency to push out a little as the mud settles, so you want to make sure the flange is totally flush to the ICF. Now these legs are 6 inches long. Our polystyrene is 2.5 inches thick, so that gives us just about 4 inches of metal here. Of course, the most important part is getting these holes in so the concrete can ooze through that and do a really nice job of holding it in place. So here's the way it's all laying out today. We've got the ready-mix truck starting to arrive out on the street. We're figuring about 9 loads over the next 4 hours to pour all the forms. Oh, we've got Jeff Siegel's concrete pump stationed here to take the concrete here and send it out on the hydraulic boom to where the forms are. And that's where Brad's got his crew, controlling the pour and working the concrete as it goes into the middle of those ICFs. So Brad, it takes a while for the walls to go up, but once those are up, this concrete pour, this is like a 4-hour operation, right?
Right, it takes about 20 minutes to empty a truck, so that's what we ask for in spacing.
And then once you are pouring, you tend to just go around the whole perimeter 3 or 4 times in different lifts, or do you basically fill up a spot and then move on?
No, we'll do 3 or 4 lifts on walls this high. Let the concrete set up a bit so as not to have too much pressure. We don't want any forms to fail. And then we can consolidate the concrete well too.
Now, the way these things are done here today, the way they're manufactured, there's a lot of room for concrete to flow down here. So you're not really worried about creating voids or anything too much, are you?
Right, we'll vibrate the walls, especially around openings. But if we get the right slump on the concrete mix, we shouldn't have to do too much of that.
So what do you mean by slump?
Well, slump is how they measure how fluid the concrete is. So the higher the slump rate, the looser the concrete.
And so if it's too loose, you just build up too much pressure, I suppose.
Right, right. And ends up with not as strong a concrete.
And then if it's too thick, probably plug up just hose.
Yep, and then we have a hard time consolidating it. And we want good, warm concrete on a cold day like today.
You might recall the special stone ledge forms we talked about last time when Brad was putting the basement walls together. With rebar and concrete, they provide a literally rock-solid platform for setting natural stone later on. And with these, it's advisable to know exactly where the finished grade will end up, so the bottom of the stone is not too high or too low. Now, you take a look at the way that hose is used. I mean, without a pump truck, I mean, you'd end up with like planks and wheelbarrows dumping in on the top or something. It'd be impossible.
Or 100 guys with 5-gallon buckets.
Or the old bucket brigade going on, huh? Yeah, that would not be a lot of fun. So once all the concrete's poured, you have those big walls that are tilting in a little bit. I mean, that you do that by design, right?
Right. We'll have the corners plumb, but then before we pour, we lean in the center sections of the wall.
So with concrete in the forms, it's a matter of just kind of cranking those babies down and getting all nice and plumb.
Yep, plumb in the corners, straight in between.
And now as Brad and the guys finish filling up the ICFs, I know I've said it many times, but a very important part about doing a well-built home is making sure you do a good job waterproofing the lower level. We've got a product here that's definitely going to get the job done. Two-part system. The first part, we've got the 40 mil peel and stick membrane that starts on the top, runs all the way down the ICF, and laps over the top of the footing. That seals it up tight, so if any moisture gets in there, it'll just roll down the top of the footing and drain harmlessly away. And secondly, you cover that with a dimpled drain board that really protects the membrane from hydrostatic pressure that can build up in the soil outside your foundation. The dimpled surface channels any moisture down the bottom of the wall, where it just rolls harmlessly over the top of the footing away from the house.